gravitation. What is meant by gravitation? Gravitation से क्या समझते हैं? मीन्स कुछ कुछ ग्रेविटी से मिलता जुलता है, राइट? ग्रेविटी, ग्रेविटेशन. तो जितने भी दुनिया में ऑब्जेक्ट हैं, whatsoever be the object, are applying force on each other. Are applying force on each other. Every body in the universe, all the bodies in the universe are applying force towards each other, no matter how far that body is from the other body. Okay, so जैसे कि this we just because of gravitation only we are staying on this earth, right? We can stand on this earth just because of gravitation. What are you doing, Arham? What are you doing? You're doing something else. Okay, so what gravitation is what? Everybody means like this pen is also applying force on me, and I'm also applying force on it. We are also attracting each other. Okay, but this force is too less that it will come very weak. This force is very weak. Okay, that it cannot come towards us if I leave it. If I leave it, it will go towards the ground. Why? Because earth is applying a very strong force on it. No, not just on it, but on us also, on everything also. Means on the moon also, it's applying force. Just because of that, the moon revolves around the earth. And the whole and the most importantly, the sun is right now the sun is applying the greatest force, so that all the whole system is revolving around it, right? Just because of gravitation. So gravitation, it was given by it actually is, you can say it actually is not so Newton's fourth law. Yes, Newton's fourth law.
Ma'am, is it true? Ma'am, in class I told my friends that they were laughing at me.
No. You can say that it's Newton's fourth law, but don't say it like a fourth law of motion. It's not of motion.
No. I just said it's fourth law. It's not fourth law. There are 3 laws of motion, and one is the law of gravitation.
Yeah, it's law of gravitation. But Newton's fourth law is law of gravitation. Law of gravitation. Okay. So what is it? In what factors does the force depend that is being applied on each other? Okay. The factors are the masses of the two bodies, M1 and M2, and the distance between the bodies. And the distance between the bodies, the square of the distance between the bodies. Now, how these two are related to the force? First, we'll see the formula. The statement. What does it? That's right. Every body in the universe attracts every other body with a force which is directly proportional to the product of their masses. The product of their means two. If you are taking two masses, then they are taking two objects and their masses are then the product of their masses, it will be directly proportional to the product of their masses. Directly proportional means if the masses will increase, then the force will increase. ये बढ़े तो ये बढ़े, ये घटे तो ये घटे, मास घटे तो फोर्स घटे, मास बढ़े तो फोर्स बढ़े. ठीक है. And both on M1 and M2, it's the product. Okay, it depends on the product of the masses of two bodies. And second thing is it is inversely proportional to the square of distance between them. It is inversely proportional to the square of distance between them. Means there are two masses of with the distance between them as r. Then how the force will get related? Force will be inversely proportional to the
1 by r square.
Inversely proportional to the 1 by r square. Nahi. Inversely proportional to the square of distance. And if you are saying f is proportional to 1 by r square, okay, if you are saying proportional, then you have to mention 1 by r square. And you have already said, if you have already said inversely proportional, then you will say r square. Arun, please go mute. Then you will say just what? You will say just if you have already mentioned, how do I write? If you have already mentioned that inversely proportional, then you don't have to mention 1 by r square. You just have to mention
M1 and 2 divided by r square.
Okay, inversely proportional to r square, because you have already mentioned this inversely. What happened to Advika? She is joining and rejoining, leaving. Okay, inversely proportional to r square. Now, In other words, what we can say, gravitational force is a non-contact force. Okay, gravitational force is a. Did I share the handout of gravitation? No, I forgot to share the handout of gravitation. It's
Yes, ma'am. Ma'am, you said this.
but it's there in the Alamgul app. It's there in the app, but I forgot to share it in WhatsApp. Okay. So gravitation force is a non-contact force. It doesn't is a non-contact force means what? What do you understand by non-contact force?
Ma'am, forces that like cause change with no contact, like they don't touch.
Yes. Yes, Advika?
Ma'am, like magnetic force, ma'am.
Like magnetic force. Means non-contact force means what? Means it's not necessary that the two bodies should be in contact with each other so that this force can be applied. This is not necessary. Any force, anybody from anywhere can apply this gravitational force on each other. Okay, it doesn't. If we are standing on the ground, then only the earth is applying force on us. It's not that. If we are on the terrace, if we are jumping for that moment also, the force is being applied by the gravitational force is being applied by the earth. if we are जैसे हम कहीं पहाड़ से कूद रहे हैं तो it doesn't mean कि वो force apply नहीं होगा. पहाड़ से कूद रहे हैं तो वो force apply होगा तभी हम नीचे जाएंगे, right? तभी हम नीचे जाएंगे, है ना? तो कांटेक्ट होना जरूरी नहीं है कि दो फोर्सेस कांटेक्ट में रहें. दो फोर्सेस कांटेक्ट में रहें ये जरूरी नहीं है. सॉरी, दो बॉडीज कांटेक्ट में रहें ये जरूरी नहीं है. कहीं भी रहें वो इन दोनों के बीच का डिस्टेंस r एंड इन दोनों के मासेस पे डिपेंड करेगा. इन दोनों के मासेस पे डिपेंड करेगा. ओके, सो डजंट मीन कि
deriving the formula.
यस,
Ma'am, are you deriving the formula that F equal to G_m1 and 2 to the r square?
अभी I will derive the formula. It is always attractive in nature. Why? Because it always attract the other one body attracts the other body. It is always attractive in nature. Okay, so one body attracts the other, pull the body towards it. Yeah. Depends directly on the masses and inversely to the square of distance between them. So directly on the masses means what? It will be directly on the masses means m1 and m2. This force will be directly proportional to m1, m2. Okay, directly on the masses and inversely on the square of distance between them means 1 by r square. Force will be inversely proportional to the square of the distance. Now inverse square law applicable. Inverse square law means अभी हम लोग derive करेंगे formula. Okay, inverse square law means inverse means 1 upon square law means this, the square of distance. Okay, applicable to charges, masses, magnetic poles. ये सबसे applicable होते हैं. Charges like positive and negative, they also apply forces on each other, and it doesn't mean it's not necessary that they are in contact with each other. Okay, if they are if they are at some distance, then also the force can be applied. Then also the forces can be applied. Its formula is like something, force is equal to 4 pi epsilon naught q1 q2 by r square. So q1 q2 in place of m1 and m2 there is q1 and q2. There is what? Q1 and Q2 means the charges on the plus charge and the charge of negative. The charge of positive and the charge of negative. Q1, Q2 by r square. Okay. So r square is the same, just like the distance between them, right? Now masses that we are going through m1 and m2. Magnetic poles is just like north pole and south pole. Magnetic poles just like north pole and south pole. They also apply forces on each other. North pole and south pole attract each other, right? And from some distance only. Okay, so these are the things. Okay, so this is very important that this, what does it state? Now we'll derive the formula. Let this be mass m1 and let this be mass m2. Okay, and see, whatever the force is, this F1 is being applied now. This F1 is being applied to this mass, right? And who is applying this mass? Who is applying this? Who is applying this force? This force is being applied by this mass. This force is being applied by this mass. This gray force is being applied by this gray ball. Okay, this gray force means F1 is being applied by M2, and this.
Ma'am, both of them applies equal force on each other now from the center.
And they both apply, means like every particle of this ball is applying force to every particle of this ball. Okay, means इसके हर particles, there are many particles, thousand and infinite particles, right? So इसके हर particles पे force लगा रहे हैं, but we cannot take like this particle to this particle, this particle to this particle. So we take just one particle, we take just from its center and its center. This center is applying force, this center is applying force to this ball by F1. Okay, and this ball is applying force. This red ball is applying force. Red ball is applying force on this ball by F2. F2 is the force that is being applied by it. Okay, and these will be equal forces, right? Yes, these will be equal forces. So it does not mention to be the F2 F1. Fine. So what will be the force? We can cancel this. What will be the force? As already we have seen, it depends on what? The product of the masses of two bodies, M1 and M2. Okay, and here we have taken a small letter, so we will take a small letter. Whatever letter we will be taking in the diagram, that will take in the that will follow in the whole solution. Okay, or proof, whatever you say. So F is directly proportional to M1 M2, and F is inversely proportional to R square. It means that we can write it, yes, 1 by R square. It means that we can write it M1 M2 by R square. Now we need to make formula, we need equal to sign here, right? In place of proportionality, we need equal to sign. So we will remove this proportionality sign, and we don't know what other factors that the force is डिपेंडेंट ऑन इट. ओके, किस और फैक्टर पे फोर्स डिपेंड हो रहा है हमें ये नहीं पता, इसीलिए हम लोग के लगा लेंगे एंड M1 M2 by R square. This will be our formula.
Ma'am, what about the G, ma'am, which we use over there?
Sorry. This K is called the G. This K is G here. Means generally we put what? K, na? K is what? G here. G is constant. Okay, fine. So the value of this G is what? 6.67
10 to the power minus 11 Newton meter square. Newton meter square divided by kg meter square.
Newton meter square divided by kg square. So now you say where you have got this.
We'll put the units in the formula and we'll get the value.
Advika, do you know where we have got this from? Advika, can you tell me where we have got this from? This unit. Are you there?
Can you hear me?
Yes.
Ma'am, Newton meters is kg is the weight for mass, and Newton meters is
where we have got this unit from.
Force by
your voice is breaking. Okay, it means that you want to say like G. We have just rearranged this equation and wrote it like.
Ma'am, it's basically force. Can
we write it like this for G?
Yes, ma'am.
And just we will put the unit in place of the. You'll pay.
Ma'am, will become yes, ma'am. So it will become Newton into meters by
kg square. So it has become Newton meter square per kg square. We can write it in this fashion also. Okay, Newton meter square per kg square. So this is what the unit of G is. This is called gravitational constant.
Ma'am, isn't like gravity like a form of force? So can't we just use the unit of force like Newton?
Yes.
Ma'am, isn't gravitational force a type of force? So can't we just use Newton's?
Gravitational force. What's your time from?
But she's asking that can we use like gravity is also force, so can we use Newton in gravity also?
Means you want to write G as G?
No, ma'am.
Yes.
Ma'am, what am I?
There are two G's. One is acceleration due to gravity and one is different to law of gravity.
Yes, ma'am. I told you this.
I'm not getting you. What you are trying to say?
Ma'am, she's saying that since gravity is a force, can't we write it in Newtons?
No, we cannot write it in Newton. This is gravitational constant. This is not the force. This is the constant. This is universal law of gravitation. This is universal constant. This is gravitational constant. This is force, and this is dependent on M1, M2, and R square. And also, we are not knowing in what factor, in what other factor that force is dependent on. So we have put here G, and when you will and then mean something, and here it has been found the value for G is 6.67 to 10 power minus 11 Newton meter square per kg square. So we have to find the unit for G. Now it cannot be in Newton. How can it be Newton? Means can it be like F is Newton is equal to Newton meter square by kg square? Can it be like this?
No.
So in the LHS and in the RHS, are these the same?
No.
So there must be some unit which will cancel out, so that which will cancel out each other, and only Newton will be left in the Newton should be left in the right hand side also. Okay, so the left hand side and the right hand side unit should also be
Equal.
same,
Okay.
right? So we cannot write the unit for this is derived unit. These all are derived units. This Newton and this Newton meter square per kg square are the derived units, and these meter and kg are the fundamental units, right? These are called the fundamental units, and other units like a force and force and thrust and whatever be the means of what other things are. Even speed. These the unit of these are derived units. These are called the derived units. Speed for meter per second. This has been got derived from meter, means distance, the unit of distance, and unit of time. So these are the fundamental units. This for distance means meter and second. But speed, the unit of speed is derived unit. This is also likewise here also the unit for G. We have derived this unit for G. Okay, we have derived this unit for
Mama.
Okay, so this is called the gravitational constant, and this is your this is what the value for the gravitational constant.
That's the unit.
Now, if we are given two masses of 1 kg each are separated by a distance of 1 meter, find the force of gravitation between them. Okay, two masses of 1 kg. So 1 kg is
Ma'am, are these questions from NCRT?
Not all questions are from. I think this question is from NCRT only.
Yes, ma'am, because I have done all these 3 questions.
Okay, this actually
and one
is given as like this also. This actually is given in here also. The where f is equal to g where comes. So this also means if masses and the distance between them is 1 meter, then what will be the force? So it will be equal to g. Then we have to in the form of question also it's asked in the paper. Okay, the two masses of m1 and m2 are the same, that is 1 kg, and separated by a distance of r square. So distance is equal to r is equal to 1 meter here. So find the force of gravitation. Just write the formula first. M1, M2. So G is equal to 1 into 1. 1 into 1 by 1 square. So all will get cancelled. 1, 1, 1, 1. All will get cancelled. Multiplied and divided. So we will get F is equal to G. The value for F will be equal to G once all the masses and the distance between them we have taken as 1. Okay. Now the second question is the mass of Earth. Can you do this question by yourself? Mass of this will involve some kind of calculation. Okay, exponents, the calculation of exponents. So don't get confused in solving this question. So the mass of the Earth is m1 is equal to 6 into 10 power 24 kg, and that of the moon is 7.4. So m2 is 7.4 into 10 power 22 kg. If the distance between the Earth and the moon is, so r is given as 3.84 into 10 power 5 kilometer, means we can convert it into meter so that it will become 8. Will it be or not? Yes or no? We have to take the
Yes, ma'am.
standard unit. Okay, so calculate the force exerted by it, and it's the G is being given. Sometimes G is given, but you have to remember its unit. Okay, you have to learn its unit always. So it's not necessary that you will be given with the value of G every time. So what will be the force? G m1 m2 by r square. So G is 6.7 into 10 power minus 11 into m1. M1 is what? 6 into 10 power 24, and m2 is what? 7.4 into 10 power 22. 7.4 into 10 power 22 upon G upon r square. Sorry, r square 3.84 into 10 power 8. 3.84 into 3.84 into 10 power 8 means 10 power 8 का स्क्वायर. सो क्या हो जाएगा? 10 power 16 हो जाएगा ना?
Yes, ma'am.
तो अब क्या करेंगे हम लोग? थोड़ा सा ज्यादा कैलकुलेशन है, बट पहले तो हम लोग
10 पावर को सिंप्लीफाई कर सकते हैं।
10 पावर को सारे को सेपरेट करेंगे हम लोग, तो 22 and 11 कितना हो जाएगा? इट विल बिकम 11, राइट? 22 and -11 इट विल बिकम 11, ओके। एंड 11 इसमें हम ऐड कर देंगे तो क्या बन जाएगा? 35।
35
एंड 35 फिर ऊपर इसको लेके जाएंगे तो -16 कर देंगे तो वो क्या बन जाएगा? What it will be? How much it will be? 9 and
yes ma'am, 9 and
90.
super 19
It will be into 10 power 19 in the numerator. Because you are getting a Aram also. What I'm doing?
Yes, ma'am.
हाँ, I'm just minus and plus कर रहे हैं और कुछ नहीं.
Ma'am, yes, ma'am. So basically, like cutting the since the base is the same thing, we're cutting it.
3.84 into 3.84. Now इसको करना थोड़ा सा मुश्किल बात है, लेकिन फिर भी कर सकते हैं हम लोग. तो देखो, एक काम करते हैं 6.7 को हम लोग 6 सिर्फ लिख देते हैं, ठीक है? हालांकि इसको 7 लिख सकते हैं, 6 सिर्फ लिख देते हैं. Into 6 into we'll get approximate value, okay? Approx value. It's not necessary that we are going to get एकदम exact value. So or we can do one thing. इसको हम लोग 7 लिख दें और 7.4 को हम लोग 7 लिख दें. Can we do it? Can we do it? इसको हम 7 लिख दिए, 6.7 को राउंड ऑफ करके 7 लिख दिए, 7.4 को राउंड ऑफ करके 7 लिख दिए, ठीक है? And then 3.84 and 3.84. So what can we do to this?
If the writer is 4 into 4.
4 into 4 ज्यादा बड़ा हो जाएगा. 4 into 3.84, 3.84. So we'll take
Like 14 something.
3.84, 3.84. If 4 लेंगे तो बहुत बड़ा हो जाएगा. It will be 4 then 16. So
I think it should be like 14.7 something, right? It should be like 14.7 something.
We can multiply it. You can do these things. It will just it will waste a lot of time. 3.84, 3.8, 8 for the 32, 3. So 3 for the 12, 13, 14, 15. 8 for the 32, 3, 8 is 64, 65, 66, 67, 6, 8 is 24.
Ma'am, can't you take 3.84 as 4?
3 4s are 12, 1, 3 8s are 24, 5, 2, 3 3s are 9, 10, 11. So 6, 5, 7, 5, 2, 7, 5, 12, 12 to 14, 1, 7, 4, 1. So how much it will be? 1, 2, 3, 4. 1, 2, 3, 4.
14.75.
Okay. 14.74. So we can write it like 15 लिख देते हैं, ठीक है? तो 7 7s are 49. 49 into 6, how much it will be? इतना न्यूटन आएगा. You need to mention Newton. So
like around 300, 293 something. 293.
49 to 6 to 84.
293 or whatever. 294.
4 7s are
294.
294.
294. Sure ना? 294. So 15 से करेंगे. 15 1s are 15. 4 and 1 and 4 will come here. So in how many times? 15. 9s are 135. Okay. 9 and then 0 0. So 0.0 90. 15 6 are 90. 19.6, around 19.6 into 10 power 90. Okay. So around itna Newton आ जाएगा. Don't forget the unit. Okay. So what we did, we just put the formula, put the values on the formula. Okay, in the formula. So what is the magnitude of gravitational force between Earth and a 1 kg object? This is what? See, this is what it is, that whatever force that is being applied by Earth on us. Like this is Earth. Okay, this is Earth, and this is something on the Earth. Okay, this is something on the Earth. What is the magnitude of gravitational force and a 1 kg object? So 1 kg object, what is the value of 1 kg object? What it will be if it will be here in the 1 kg object? There will be some kind of radius of this object also. But what can be the value of this object? What can be the value of the radius of this object before this? The radius of this Earth, will it be something, or it will be negligible? This will be negligible, right? ये जो ऑब्जेक्ट रखा हुआ है अर्थ पे, इसका जो रेडियस होगा वो नेग्लिजिबल होगा ना रेडियस अर्थ के, राइट? We will only take the radius of Earth as the distance between the body and the Earth, because what we take the distance from the centers of the bodies, right? We take the distances from the centers of the body. So what it will be? If this is our Earth and object is kept on the Earth, then what can be the radius of this? What can be the radius of this? What can be the radius of this object in front of this radius, this huge mass radius? It will be negligible. So we'll take only the radius of the Earth as their distance, as their distances. Okay. So here we are given m1 as 1 kg, and m2 as mass of the Earth is 6.4 into 10 power 6. Sorry. 6 into 10 power 24. 6 into 10 power 24 kg. Okay. So this is the mass, and distance between them is what? Distance will be what? The radius of the Earth. Distance will be the radius of the Earth. 6.4 into 10 power 6 meter. This will be the radius. Okay. 6.4 into 10 power 6 meter. Then now applying the formula, F is equal to G m1 m2 by r square. So here 6.7 into 10 power minus 11 into m1 is 1, so need not to mention, also you can mention 6 into 10 power 24 upon r square. R will be what? 6.4 into 6.4 into 10 power, it's 10 power 6, so it will become 12. So once you will do it, you will find out its answer to be 9.8 Newton. What do is it correct or not? 9.8 Newton. We always take 9.8 Newton as G now. This is what
Acceleration due to gravity.
Acceleration due to gravity. This is the acceleration due to gravity. When we'll take like 1 kg object, if there is 1 kg object on the Earth, kept on the Earth, then what force will the Earth apply on that mass will be 9.8 Newton. Okay, this is what we take while we do the questions of gravity. Right? This is what we take the value for G. Okay, in whatever question we take now, like half GT square, also UT plus half GT square when the object is being coming towards the Earth.
But we take it as 10 meters per second square approximately to make
Yes,
the calculation more easier.
10 square approximately, just to get the answer jaldi se. Okay. Sometimes it's also given in the question. Sometimes it's also given in the question that take G as 9, take G as 10, and if it's not given, then you have to take the G as 9.8. Okay. Universal law of gravitation. What things that it explains? See, universal law of gravitation. What the tides in the ocean are due to the gravitation. The moon and the sun pulls the. This is your sun. This is your moon. When the suns and moon are just in opposite direction with the sun, with the Earth, ना, then मेरा जी ज्यादा बड़ा हो गया, सन से बड़ा अर्थ हो गया, तब क्या होते हैं? टाइड उठते हैं. टाइड जो उठते हैं ना, लहर बड़ी बड़ी, वो किसकी वजह से होते हैं? इसके ग्रेविटेशनल की वजह, इसके ग्रेविटेशनल फोर्स की वजह से, इसके ग्रेविटेशनल
from moon and sun.
What?
From moon and sun both.
From moon and sun both. This is what I have drawn here. Na? From moon, this is your moon. This is your sun. This is your earth. Okay? So, सबसे ज्यादा टाइड तभी उठते हैं जब ये दोनों क्या होते हैं? एक इधर होता है, एक इधर होता है. सबसे ज्यादा टाइड्स तब होते हैं, सबसे बड़े बड़े लहरें. The forces that binds us to the earth is due to the gravitational force. The motion of the moon around the earth is due to the gravitational force. The motion of planets around the sun is due to the gravitational force. The occurrence of tides is due to the gravitational force of attraction of moon and sun also. And sun. The flow of water in rivers is also due to the gravitational force of the earth of water. Okay? The flow of water in rivers is also due to the gravitational force of the earth on water. ओके. अर्थ जो है ग्रेविटेशनल फोर्स लगाता है, इसीलिए लहरें जो है उठती रहती है, फ्लो वाटर जो है फ्लो करता है. ठीक है. Motion of moon around the earth and centripetal force. Centripetal, we are running out of time. Centripetal force is what now? Centripetal force is just the force from the inside, like the sun is revolving around the moon is revolving around the earth due to the centripetal force, because in the center the earth जो है वो अप्लाई कर रही रहती है फोर्स ऑन द मून. इसकी वजह से क्या होता है? मून जो है वो घूमता रहता है, और जैसे वो फोर्स जो है वो हटेगा, जैसे फोर्स हटेगा वो टेंजेंशियली भाग जाएगा. लाइक एक कोई स्टोन लेकर के, स्टोन कभी तुम लोग किए होगे, स्टोन लेकर के उसमें देख लो, टाई करो एक धागा को. ठीक है. टाई करो एक धागा को, वो क्या होगा? ऐसे 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 घुमाओगे. ठीक है. घुमाते हैं तो वो घूमता है बहुत तेज. राइट. हाथ से घुमाएंगे तो घूमेगा, और वो हमारे हाथ का फोर्स जो है वो सिर्फ उसे बांधे रखा है, और वो उसे रिवॉल्व करा रहा है. राइट. रिवॉल्व करा. जब भी हम उस धागा को रिलीज करेंगे, as soon as we release that thread, it will rush out.
Yes, ma'am.
right? Rush out immediately,
Yes.
just from that point tangentially. Means like this. If we are,
Yes, ma'am. Ma'am, we take a line that's known as tangent.
if we just release it from here, if we release it from here, like this rope has this stone has reached up to here. If we release it here, it
Go
will
straight.
just straight tangential. It will rush up
Move
tangential,
on a tangent.
right?
Yes,
It
ma'am.
will forming 90 degree with it, with the center. Okay, so rest of the things we'll discuss in the next class also. And you next is Kepler's law of planetary motion. Okay, we'll be discussing this. Acceleration due to gravity, free fall. Okay, fine. Then we can close it for today, and then we'll continue in the next class. Okay.
Okay, ma'am.
Okay, bye.